Okay, we have here an interesting problem from MIT Integration Bee 2023 Semifinals Round 2, Problem 4. We have the integral of sine 4 arctan of x dx. Okay, the way I like to do these kind of problems is just to notice whenever we have an inverse trig function, we can think about that as an angle. So if I want, let's just kind of get rid of this for the moment and write this, instead of writing it as 4 arctan of x, let's write it as 4t. Because I think it's easier to look at this way. We just have to remember, of course, that t is going to be arctan of x. I'm not going to differentiate this. We can just put it back later. We just have to remember before we integrate, we need to get this back into x because you can't integrate when you've got two different variables like that. But then let me write this a little bit of a different way. Instead of writing it as 4t, I can write this as 2 times 2t. And then what we can do is use our double angle formula for sine. Sine 2x is the same thing as sine x cos x. So then using it on this, when we have sine of 2 times 2t, this is going to become 2, but now our input is this 2t, so it's going to be sine 2t cos 2t. But now I can just use the double angle formula again, because this is exactly this with a different variable. So now what we have is 2, bring another 2 out, sine t cos t. I'm just trying to get it all back to a single angle, just a t. But now 2 times 2, let's put that and write that as a 4. And then for cosine 2t, let's use the double angle formula on that. I know 3 versions of this. There's 3 versions of this formula. I think what I want to use is, I don't think it's really going to matter actually, but let's use 2 cosine squared t minus 1. You could also write it as 1 minus 2 sine squared t, or you could do it as cosine squared t minus sine squared t. So let's take this and plug this back in here. And then next, let's just distribute this inside the parentheses and see what we have. This is going to become 8 sine t, and then we're going to have cosine cubed t. And then for the second part, it's just going to be minus 4 sine t cos t. But now before I put it back in the integral, remember we want to get this all the way back to x. This is where we'll come back and we'll use this, but let's rearrange this. If we take tangent on both sides, we have an expression like x is going to be just equal to tan of t. Now for this, I can just draw our right triangle. So the angle on it is just going to be t. I can write this as x over 1. So tan of t, opposite over adjacent, x over 1. Pythagorean theorem, get the third side, square root of x squared plus 1. So now that we have 3 sides, we can find out our values, because we're going to need sine t and cosine t. So for sine t, opposite over hypotenuse, that's going to be x over square root x squared plus 1. And then cosine t, adjacent over hypotenuse, is going to be 1 over square root x squared plus 1. So let's take what we found here and just substitute it back in here to get everything in terms of x. So if we multiply, so like sine t times cosine t is going to be x over x squared plus 1. And let's see, to make this easy on ourselves, let's get an expression. If we have sine t cosine t, we just multiply these together and we get x over x squared plus 1. And then notice that cosine squared t, that's really easy. That's just going to be 1 over x squared plus 1. So sine t cosine cubed t is just going to be this thing times this thing. So what that's going to give us is it's going to be x over x squared plus 1 all squared. And then for the second part, we have minus 4 of this, which is just x over x squared plus 1. And so now let's just take this thing, plug it back into the integral, and see if we can finish it off. Okay, now from here we have 2 easy integrals to do. I'm actually going to do a u-substitution on both of them. We can do the same u-substitution on both because we've got x squared plus 1 in common. So I'm going to set my u equal to x squared plus 1. Then du is going to be just 2x dx. In order to get the match with our du, I can multiply in 2 on both these. So we just have our du in the numerator. But so I don't change it, let's divide by 2. Go ahead with the substitution. This is going to become 4. And we're going to end up with du over u squared, but I'm going to write it as u minus 2 du. Then here this is going to become minus 2. And this one's just going to be du over u. Go ahead and integrate. This is going to become just minus 4 over u minus 2. And here we're going to have natural log absolute value of u. And then let's just back substitute in order to finish it off. So for my final solution of this, we just get minus 4 over x squared plus 1 minus 2 natural log. Drop absolute value as this is always positive. Add a plus c, and that's it. Okay, there you have it. Good one today from MIT 2023. Thanks everyone for watching. Have a good day.